Okay, so we're going to talk a little bit more about scatterplots today. Okay, do not forget, Tuesday is your benchmark. Okay.
It's on everything we've learned so far.
So it's on solving equations, solving inequalities. It's on domain and range. It's on functions. So like the f of 2. There is one standard that the state puts on it that we have not covered yet because that's covered in Unit 4. So once we get the results back, all of those questions I will exempt from your grade. Okay. So we can get an accurate.
Right, if they're right.
If they're right, I'll leave them alone. But if they're wrong, I'll exempt them so we can get an accurate score for you.
What's the name of the standard?
Like you want the actual REI dot whatever.
No, like is it like modeling? Like
We'll pull it up here in a little bit. Okay. All right. A scatter plot. A scatter plot is a graph.
And the thing, do they round the grades up?
Put the phone away or it's mine. I will address it. She put it away. Let her alone. Scatterplot is a graph with points plotted that shows a relationship between two sets of data. Okay, because this is two sets of data and there are two variables, we call this bivariate data. Think about it. In English, what does bi mean? Two. Bicycle, 2 wheels. Okay. Oh no, we learned English in math class.
Is there anything called transvariable?
I don't remember ever doing anything.
Oh, that's what 3.
Yes.
Yeah.
It would actually be a tri-variable,
Yeah.
not transvariable.
You learn about
But I knew where you were going with that.
You learn about trinomials?
We actually are.
Trinomials?
Monomials, binomials, trinomials,
Wait, what is
polynomials.
that again? I did. Yeah, I was good at that.
What is
Hopefully,
stapler?
I think so.
Who has the stapler from over there?
Do I have it?
I don't know. I had 2 staplers.
David got it.
David, get off your phone or I'm taking yours. Noah did, but he's got mine. It's all good. Hogging the stapler back there. I see you. I see you. I see you hogging the stapler. All right. So, creating a scatter plot. Okay. It's literally like putting dots on a graph using X and Y. So, my hours are along the bottom, so that's my X value. My scores are along the side, so that is my Y value. So we needed a point at 2.5, comma 68. So 2.5 is here, and 68 is around about here-ish. Okay, it's not going to be perfect. That's okay. Okay, so we did this one. 0.5, comma 71. So 0.5 and 71. Four and 98. Three and 91. Notice I like to check mine off as I go so I make sure I don't miss any. 0.25 and 40. 3.5 and 83. 2 and 75. 1 and 60. 2.75 and 85. 1.5 and 70. 3.75 and 93. Okay. Yesterday we talked about the different types of correlation. So once you get your graph done, what type of correlation does this graph look like?
Positive.
Positive. Okay. Would you say this was strong positive or weak positive?
Strong.
This is close on the strong side. So this is a strong positive correlation. Okay. Questions or problems with that part? Okay. All right. If you flip the page, at the top, it says association. Guess what? This is just another word for correlation. Okay. So they can interchange those two words. They can call it an association or a correlation. Okay. So it's just a set of describes how sets of data are related. So positive, negative, or none. So the first picture is what kind of association? Positive. And again, that means as X increases, Y increases. Actually, let me not do increase. As X goes to the right, Y goes up. Okay. Because remember, increase on your X is going to the right. Okay. The second one then is negative, which means as X goes to the right, Y goes down now. And this one is none or no. And this is just no relationship. Emails. Okay, so there can be things that happen. Okay, things that just don't belong or things that are just a little weird. Okay, so we've got two types of things. The first one is called a cluster. A cluster is a set of data that is closely grouped together. The data can cluster around a point or a line. And then we have an outlier. Does anybody remember what an outlier was? Okay.
But
When it's all by itself, okay, whether it be way above the data, way below the data, way to the left, way to the right. It's just something that doesn't belong. So an outlier is a data point that is very different. It's special from the rest of the data in the set. Can I have more than one outlier? Yeah. So an outlier actually affects how the data goes. And when we talk about mean, median, mode, and range at the end, that's unit 8, we will talk about the effects of outliers on mean, median, mode, and range. So in this picture, identify any clusters. Where are my clusters in this picture? Okay. Right around here and right here. I actually have 2 sets of clusters. Okay. Okay. What's my outlier? What is that point? 35.29, 35.28. I would take either. Okay. It's pretty close. Okay. Questions? All right. We're going to talk more about this next week, but just to get a general idea, we have something called a trend line. Okay. They call this, you're right, that is a straight. Yep, you're good. It's a straight line. Okay. They can also call this a line of best fit. So you're going to actually draw a line through your data, okay, that best fits the data. However, there are some things that you need to keep in mind when you're drawing your line, okay? So there are approximately the same number of points that are going to be above the line that you draw as well as below the line that you draw. And they want you to ignore any outliers when you draw your line, okay? Pretend like they're not there. Okay. I guess we should have passed out rulers, huh? That way you can actually draw a straight line. Okay, before we draw our lines here, do I have any outliers in this picture? Okay. Okay. I would say that point at 6, what is that, like 350?
Yeah.
Okay. 3 something. Okay. That point right there is probably an outlier. Okay. I wouldn't count it when you're drawing your lines. Enough. Again, please be gentle. These are just from the dollar store or things that people have given me down the road. So they're pretty kind of cheap. Okay, so we're going to identify this as an outlier. Okay, so when I draw my line of best fit, I want to try to have as many dots above my line as below my line. So when I go to draw this, I'm actually going to draw mine kind of like probably about here-ish. Okay, probably about here-ish. I've got 3 points above my line 3 points below my line, and 2 points basically on my line. Okay. So just keep that in mind when you're drawing your trend lines or your lines of best fit. So using my line of best fit, they want us to predict how much you should expect to have to pay in repairs for an 8-year-old car. So if my car's 8, what should I expect?
8. No.
Remember, 8's here.
No.
Okay, so depending on where you drew your line, mine actually almost touches it like 1,000. Okay. Some of yours might have been a little bit more slanted. So if it's 970, put 970. Okay. Mine's closer to 1,000, so I'm going to put approximately 1,000. It all depends on. So if you kind of curved your line a little bit more like this, yours would be at like 970. Okay. Okay. We're definitely going to deal with this more next week. But let's get a general sense of what we're going to do next week. So next week, I'm going to show you how to do all this by hand. Then I'm also going to show you that your calculator will do this for you. Okay. So they want us to find the slope, find the y-intercept, and give them an equation that fits that line. So in order to find the slope, remember, I need 2 points. So find me 2 points that fall on the line. He said 5 and 500. So 5 and 700. Careful, 5 and 700 is way up here. Is that actually on your line? Yeah, on your actual line itself. So mine's like 5,600-ish. Okay, you want actually on the line that you drew, not just any point that's on the graph.
So do you use your line or our line?
What about 40 and 550? No.
Let's use my line just for purposes that everybody's is going to match then. So let's do 5 and 600. What's another point that my line crosses? You said 4 and 500? Okay. You could use 4 and 500. You could even use 1 and 100 way down here. Okay. So which one do we want to use? I got 5 and 600. Do you want to use 1 and 100 or 4 and 500?
1 and 100.
Okay. 1 and 100. Okay, so to find the slope, I need to find the change in my y. So I'm going from 100 to 600. That's 500. It increases by 500. My x's are going from 1 to 5, so that's an increase of 4. Well, what's 500 divided by 4? No, it's going to be 120, 25. Okay, so 125. So my slope is approximately 125. Okay, you never want to say that it's absolute because you do not know that. If you drew your line wrong, it's not absolute. Okay, your calculator will give you absolute. Your prediction, remember, you're a human. We all make errors. Okay. Okay, to find the y-intercept then, remember, y equals mx plus b. So all I know right now is m is 125. I need to figure out what b is. I need to know what my y-intercept is. Okay, pick either one of these points. Which one you want to use? 1 and 100. So if I use 1 and 100, my y value is 100. My x value is a 1. Now I can find b. Because this is now 100 equals 125 plus b, because 125 times 1. Subtract 125 from both sides. So negative 25 equals b. So your final equation then, according to my line of best fit, is y equals 125x minus 25. Okay. The people that did the answer key that actually goes with this that I bought, they got a line of y equals 133x minus 33. Okay. Because their 2 points were different. Because their line was a little bit different. Okay. So answers can vary if you're doing this by human. Answers will not vary if you're using your calculator. So this clues in on 75 if you've not done so. And we need to talk about ice cream sales. Makes me hungry. I what? I can't hear you.
Did you film for YouTube?
Yeah, we're still on YouTube.
Okay.
She wants to say, hey, YouTube. All right. So this one, ice cream sales. Okay, this was obviously done by a computer. Okay, they're giving us very accurate data here. Okay, they already gave us the 2 points. Okay, so let's find the slope, and they want to know, what does the slope mean? So again, my slope is my change in y. So my y's are going from 325 up to 614. You may need your calculator on your phone to do this one. You said 81? 89. Okay, 89 divided by my change in x. I'm going from 16.4 to 25.1. You said what? 8.7. So what do we get when we take 89 divided by 8.7? 10.2. Okay. What does that mean? What does 10.2 represent? Yes, but what does it mean? According to this graph, what does that mean? I mean, does it mean for every 7 cows that I have, we're going to have 10 gallons of milk? What does that mean?
It means the higher the temperature goes, the more ice cream it is.
So 89 is your money. Okay. 89 is your money. It's your change in Y. So my money increases. So the money increases by 10.2 per, what does X represent? Temp in Celsius. So every time the temperature goes up by 1 degree Celsius, we sell about $10.2 more of ice cream. Just by 1 degree Celsius. Okay, so you've got to think about what Y means and what X means when you're determining slope. Okay, my y-intercept. Well, I've got to find that first. All right, here we go. So pick either one of the points. Which one do you want to use? Okay, so that means y is 325. We know my slope is now 10.2, and we know x is 16.4. Okay. So now I need to solve that for my y-intercept. So 10.2 times 16.4 is 167.28. 167.28. Subtract that from 325. And my B is approximately 157.72. So what does that mean? Remember, this is 0, 157.72. Whoops, 72. When you're looking at it as a point. Okay, so we make approximately $157.72 when we're at 0 degrees Celsius. Anybody know what degree Fahrenheit that is? Almost.
It's 32.
32.
What do you think makes more sense? The Celsius or the
I always thought Celsius made more sense because 0 is 0.
because that's the freezing.
Right. The freezing temperature is 0.
Right.
I always preferred centimeters and millimeters instead of inches and all that stuff too.
But I like inches better. But I prefer that.
All right. So we can do 2 different things with this. We can interpolate and we can extrapolate. What? Okay, so interpolate is when you are guessing a number that should be inside of the data set. Okay, so if you go back and you look at this, any of the numbers that fall in between my data set, if I'm guessing any numbers that go in between, that's called interpolate. Okay, so they want us to find out what would be the expected sales if we're at 21 degrees Celsius. So 21 degrees, that's about here. Okay, here's 21. 21. Oh, I forgot to fill in our trend line equation. My bad. So this is y equals 10.2x plus 157.72. Okay. So 21 is right there. Because it falls within my data range, the points that I already know, we're interpolating. So, approximately how much money should we make if we're at 21 degrees Celsius? You could. We can just make a good guess if you really wanted to. Okay? But he's absolutely correct. We have an equation. We can actually solve this. Y equals 10.2. We know it's 21 for my x plus 157.72. $371.92. I wonder how big this area is, though. That seems like a lot of money. Is it just me, or does that seem like a lot of money to you too?
For ice cream.
Yeah, they must be selling a lot.
You gotta be selling more than ice cream.
Because that's technically.
That business gotta be a cover or something.
Does that have to be like a lot?
So that's 69.8 degrees Fahrenheit.
It's not even that hot.
Right. It's really not even that hot.
But that's
And
like
they're
the
selling
perfect
300.
ice cream that like you licking and melting.
You're right, though. I mean, the ice cream cone actually stays pretty well. It's not going to sit there and melt all over your hand because you're not eating it fast enough. Okay. Okay. Extrapolate means I'm predicting something that is outside of what I know. So now they want to know, what about 29 degrees? Well, 29 degrees is going to be somewhere way out here. It's outside of my data range. Okay. So when you're guessing something that is outside of what you know, extrapolate. If I'm guessing something inside, interpolate. Okay. So again, let's use our formula. Y equals 10.2 times 29 plus 157.72. Did anybody ever show you how to recall on your calculator too?
What is it?
Oh, I just used the wrong formula. Dang it. I recalled the wrong formula. There we go. Change this to 29. There we go. $453.52. That's only 84 degrees Fahrenheit.
That's a lot of degrees for ice cream. That's nothing.
It's probably expensive.
Yeah.
That'd be good though.
It gotta be like them ice creams that have the gold wrapper and all that.
Okay. Let me show you something real fast, just in case you don't know how to do it. So let's just say I want to keep changing 29 to different numbers. You know you can hit second enter, and it will bring up that equation again. And all you have to do then is scroll over and put in a new value. Whoops. And hit enter. If I want to go back 2 spaces, I just hit second enter and then second enter again, and it goes 2 up from where I was.
What if you clear it? What is it like? Won't do it?
If you clear it, I don't think you can recall anything. Oh, yes, you can.
I'm gonna clear all the way.
It still recalls.
Second, plus second.
For real?
So unless you second plus 712, which will completely clear the RAM, then it won't.
Oh. There's a way to do scatterplots on there too.
We're going to do that next week.
I remember.
We're gonna do scatter plots on there. We're gonna do line of best fit on there.